Hello guys, welcome back. So let's quickly talk about the insertion sort, which is also one of the basic sorting algorithm. So let's talk about insertion sort in this lecture, and then we will move on to the little bit advanced, we can say, or little bit crazier sorting algorithms in the next, or we can say, future lectures, right? So let's quickly see what is insertion sort, right? Let's see the definition. Okay, so then I'll explain like what it actually is. Okay, so it is a simple sorting algorithm that virtually splits the given array into the sorted and unsorted parts. Okay, then the values from the unsorted parts are picked up and placed at the end, at the correct position, not end, in the sorted array. Okay, so what does this definition means? So let's say you have an unsorted array, right? So what we basically do in the insertion sort, we check which all elements are unsorted and we pick them up and then we place them in the sorted, in their correct position. Okay, so let's say you have this array, right, which is right now, as you can see, if it is unsorted, right? So what we will do, we will first check these two elements. Okay, so we are seeing like these two elements are not in correct position. Okay, so what we will do in the next step, we will basically pick this number up from here, or let me just quickly cut it. Okay, and then we store it before 9, right, because its correct position is before 9, right? So now this part, as you can say, is sorted, right? Now we will see the next number in the next iteration. Okay, so now in the next iteration, what will happen, we will pick 7 and then we will see if it should go like after 9, before 9, after 4, before 4, right? So as you can see, the correct position of 7 is between 4 and 9. Okay, so what we will do, we will pick 7 and then we insert it in between. Okay, so now in the third step, we have these three elements as sorted, right? Now we will jump into the next iteration where we will see this number. Okay, now we have to check whether this number is like smaller than 9 or bigger than 9. It's smaller than 9, so it should go here somewhere in between. Now we will compare it with this number, whether 2 is bigger than 9, bigger than 7 or smaller than 7. Obviously it is smaller than 7, so it should go before 7 somewhere. Okay, then we have 4 as well, so we'll compare it with the 4, right? So if it is greater than 4 or smaller than 4, it is smaller than 4. So what we should decide, like it should go like before 4, right? That means at the beginning of the array. Okay, so we pick it and then we place it into its correct position. Okay, so as you can see, we are gradually building a sorted portion of the array. Okay, that is why we call it like we split the array into two halves. We split the data into two halves. One is unsorted data and one is sorted data, because here if you see, we are gradually building the sorted part. Okay, right now, like in the first step, this thing was sorted because there was just one element, because we consider the first element is always sorted, right? And then we pick two elements and then we place the second element to its correct position. Now these two numbers are sorted, and then in the third iteration, these three numbers are sorted because we have placed 7 in the correct position. And then now these four numbers are sorted because we have placed 2 in its correct position, right? Now all there is left is 3. Okay, so now let's move on to the next step where we have 3. Now we have to check whether 3 is smaller than 9. Yes, so we have another number which is 7. So 3 is smaller than 7. Yes, it is smaller than 7. And then 3 is smaller than 4. It is smaller than 4. And then 3 is greater than 2, right? It's not smaller than 2. That means we should place this number somewhere in between 2 and 4, right? So its correct position is between 2 and 4. Okay, so this is how we sort the array with the help of insertion sort, right? We pick the element, we check where we should place it, and then we place it there. And this is how we gradually build the like sorted portion of the array. Okay, so here if you see, like sorted part was just 9, right? Now here if you see, sorted part was 4 and 9, right? Here sorted part was 4, 7 and 9, right? Here sorted part was, I think, 4, 2, 4, 7, 9, right? And then here sorted part, this obviously this whole array is sorted, right? So this is how like we sort the array with the help of insertion sort. Okay, so now let's try to understand it with the help of like visual algo. Okay, so I think I made it clear so far, like how it works. Okay, so let's try to see some visual things for this algorithm. Okay, so here we have visual algo, and I have already selected insertion sort. Let me just quickly remove few numbers because this array is a little longer, right? As you can see, it's way too bigger. Let me see if I can do something here, and it already shows 2 3 4 5 elements, right? So let me quickly click on it. Okay, so now we have a little smaller array. You just have to you just pay attention to it, like how it sorts the array, right? So I've already shown you in the VS Code. Let's try to see here. Okay, now let me remove it. Let me just, okay, wait guys. So let me start it from the beginning. Now I'll play it. Okay, so as you can see, we have took 29 and 10, right? We compared 29 and 10. Since 10 was smaller than 29, so its correct position was before 29. Okay, so we will place it before 29. Okay, as you can see right now 10 was picked from the second position, and it got placed in its first position. Okay, which is before 29. Now what's happening? We have already sorted two like numbers in this whole array, right? We already have one sorted part in this whole array, right? So we have this part which is unsorted and this part which is sorted. Okay, now let's move on to the next number. So what will happen now? It will check 14. So this 14, it will compare with this number and this number, where this should go. It should go before 29 or after 29, before 10 or after 10, and then it will decide like where it should place, what is the correct position of 14. Okay, so let's see, we took out 14 and then we checked 29 and 10. So we found out like it is smaller than 29 but bigger than 10, greater than 10. That means we should place it between these two numbers, right? So that is how we placed it. Now we have these numbers sorted. Now what we will do, we'll check 37. Okay, we pulled out 37 and then we will check these three numbers, or I think these two numbers only, because this number is or I think we will not place it anywhere. It will go into its current position, right? Because it is greater than all these numbers, right? So let's see what happens. So it will check just this number. Okay, so since 37 is greater than 29, so it will go into its original position. Okay, so as you can see, after 29 it never checked back the like rest of the elements, because it's already greater than 29, right? That means we are going to place it after 29 only, right? So now we have 14. So 14, for 14 what we will do, we'll pick this out and then we will check with 37. It is smaller than 37. Then we will check with for 29. It is smaller than 29, and then we will check with 14. It is equals to 14. Okay, so we can place it here somewhere, right, between 14 and 29. So let's see. Now it is checking with the 37. Okay, so it is smaller than 37, and then we will check with 29. See, right now it is comparing 29. So we'll like move this 29 here, and then we will check with 14. Okay, okay, so it found like this element is equals to this element, but this one is greater than this one. So we should place it like right next to 14. Okay, or right before 29. Okay, this is how we decide like how to pull out the elements, how to place them in the correct position. Okay, and this is what insertion sort is all about. We pick the element, we insert them in the correct position, and this is how we gradually build the sorting portion of the array. Okay, so most people call it like we split the array in the half, and then we call the first half as sorted half and then second half as unsorted half. It's not like that, right? We pick the first element, we consider it as sorted, and then based on that first element we check the rest of the elements, and we will pick those elements and then we arrange them after or before our first element. Okay, and this is how we gradually build our sorted array, right, as you have seen here. So I hope like I made the point clear here, like how this insertion sort works. So this was a quick video. So this is it for this lecture. Now let's quickly dive into the implementation of insertion sort into the next lecture. So this is it for today, guys. See you in the next one.